Testing. Testing. Okay, so I will. Sorry for the technical problem that the line putus tadi. Saya pun tak perasan. So let me do the record again. Saya tak perasan saya sudah cakap sendiri cakap kosong 1 jam. Okay. So just now we stop at example 1C. So let's see. 1C, how we happen to solve for this question here is that we already have it at standard form. You already standardized in the form of Z. So I will suggest that whenever you already have it in the form of Z, we try to draw the bell-shaped diagram to observe how is the regions looks like. So have a quick drawing. This is a bell-shaped diagrams where you find out that the middle is 0. Here I will have less than 2.23. Here I have negative 1.13. The regions is happen to be at this part here. Then go on. What happened next is that I can't find the answer from statistical table if the region is happen to be on the left. It must have some regions on the right in order to apply the table. And we notice that this region shaded in red is actually equivalent with another regions now I shaded in blue with the corresponding value as positive 1.23 and also 2.23. And therefore, the regions in blue is equivalent to 1.23 less than Z less than 2.23. And as a result now, what you happen to see is that the regions now is in blue and it happens to be on the right. And in order to calculate these regions here, what we're going to do is that we need to consider the calculation of using Z greater minus Z greater. Again, whether you have equal sign or not doesn't matter in this case here for normal. And what is the value that we're going to use to minus the other is that, let us try to see whether the regions from 1.23 until infinity is larger or the one from 2.23 to infinity will be larger. So it's very obvious lah. If I highlight the regions in yellow from 1.23 to infinities, this is the regions. Whereas the regions that I highlight for 2.23, you will see that it's just part of the one in yellow only. And from what you see here from the regions that I shade, you'll find out that in order to get the one in blue, we can use the one in yellow minus the one in red. And the one in yellow is actually Z greater equals to 1.23. The one in red, 2.23. Then go on. Based on statistical table, you happen to find out that you have answer 0.1093 minus 0.0129. And as a result, I have 0.0964. So there goes the answer for my questions C. Then go on. We proceed with D. So what we have from D here is that we have the case of modulus. We have Z, modulus of Z greater than 1.2. And what we happen to find out that this is actually equivalent to, define the modulus, I have Z greater than 1.2, or I have Z less than negative 1.2. And further, you find out that the two events here I highlighted in blue and highlighted in yellow. The two events here is happen to be mutually exclusive because there is no such Z value that is greater than 1.2 and at the same time less than negative 1.2. So therefore, I will have the probability can be just written as Pz greater than 1.2 plus Pz less than negative 1.2. And up to here, again, we try to investigate using a bell-shaped diagrams to see what's going on. The center is 0. On the left, I have negative 1.2. On the right, I have 1.2. For the case Z greater than 1.2, this is the regions. For the case less than negative 1.2, this is the regions. And up to here, you find out that you can make use of statistical table to find out these regions I highlighted in blue. However, we can't get the answer for the region highlighted in red from table. But I noticed that these regions is happen to be equivalent with the regions highlighted in blue. In other words, dua kawasan ini dia adalah luas kawasan yang sama, and therefore the regions that highlighted in yellow, this part here, I can rewrite it in the form of Pz greater than 1.2. So the next time you will see that you have Pz greater than 1.2 plus with Pz greater than 1.2, and it's simplified as 2 times of Pz greater than 1.2. And from statistical table, you should have the answer equivalent to 2 times 0.1151, which is the result we obtained from probability Z greater than 1.2. And you simplify the answer, we have 0.2302 as our answer. So there goes the result for example 1, C and also D. Go on. For example number 2. Now we are going to do the reversing process. Just now we find the probability. Now you're given the probabilities and we want to find out what is the corresponding Z value. Just now we use the Z value, find probability. Now the other way around, from probability we find the Z value. And let's see how can we get the answer here. So start from part A. I have Pz greater than A equals to 0.6217. And before I try to refer to the table, I noticed that this value here is not possible to get the answer from the table because although I have greater, but the probability value is more than 0.5. So I need to make some adjustment in order to apply the table. And what adjustment I can make is that, let us try to see from diagrams, where is the possible location of our A. So again, the center is 0. If let's say you're not sure which is the location of A, whether it's on the left or on the right of 0, you can have a quick try and error where you consider A on the left, you consider A on the right, and you want greater than A, so we shade the corresponding regions for both of them. And now the regions is represented by this value here. The region represent the corresponding value 0.6217 here. And which region is most possible to be 0.6217? It will be the regions that more than half of the regions under the graph. So in other words, we can ignore the second diagram and just focus on the first diagram because this is the one that we're going to refer. So based on this first diagram here, we notice that in order to calculate the one shaded in red, we can just use logical thinking in such that I use overall minus the minus the regions in the left, the one that I highlighted in yellow. So I take overall minus these regions highlighted in yellow. I will get the region shaded in red, which is referring to these probabilities here. So therefore, I'm going to use the idea of 1 minus. So I have 1 minus P Z less than equals to A equals to 0.6217. So the part highlighted in yellow is actually referred to this one, Z less than equals to A. So as a result, when the time you rearrange the terms, you have Pz less than equals to A is equals to 0.3783. Now you should see that your probability value is less than 0.5. However, you still can't direct go for the answer from table because the inequality sign is less than. Then in that case, what shall we do is that, again, as a beginner, we can try to draw another diagram to observe. And actually the diagram is just happens to be this part here I highlighted in red, which is actually refer to just now the part I highlighted in yellow. And we notice that these regions here in red, I will have equivalent regions on the right hand side highlighted in blue, where the corresponding value I have here will be same magnitude as A but opposite sign. So on the right here for the one in blue, I have negative A. And therefore from there, you find out that I can have Z greater equals to minus A equals to 0.3783. Then we, based on statistical table, we try to find out what is our A value. So we're going to search in our table for normal distribution for this value, 0.3783. And let's see where is it. So let's just have a quick look on where is the part that we have this answer. So we would like to have 0.3783. So you will find out that the part that I have 0.3783, it will be referring to these regions here, this part here, the exact value. And this is corresponding to 0.31 according to the table. So therefore from there, we can come with the result to say that from table, we happen to find out that Pz greater than or greater equal 0.31 is equals to 0.3783. So next, what we do is that we compare the part I highlighted in purple now. So you have the answer negative A is equals to 0.31 and A equals to negative 0.31. So that goes the answer for the first part. Next, we're going to do the similar thing for part B. But part B, it will be happen to be harder. According to this question here, it will be harder. And let's see how it can be done here. Part B involve of modulus. And let us see how we solve for this part B here involve of modulus. So first of all, from the questions, we will begin the solution by defining the modulus. If modulus less than, it can be defined in such that I have the Z located at the middle. In front will be negative A, behind will be A, equals to 0.8472. up to this moment here, again, we make use of a diagram. We make use of a diagram to investigate how can we calculate for these situations. So based on the drawing, middle is 0. So between negative a and a, so the only possible way I can put is that I can have such formation, and this part I shaded in red will be equivalent with the value 0.8472. And go on. I noticed that the part shaded in red here can be calculated using the idea I take 1 minus the regions I highlighted in yellow and also the regions I highlighted in blue. And therefore, instead of writing P bracket minus A less than Z less than A, I can convert it become 1 minus the regions in yellow, which is Z less than equals to A, Z less than equals to negative A. So this is for the part that in yellow, followed by minus Pz greater equals to A, 0.8472. So this is for the one in blue. The next line, we rearrange the terms. I find out that I have Pz less than equals to minus A plus Pz greater equals to A is equals to 0.1528. And then up to here, we notice that the regions in yellow is this one. The regions in blue is this one. And these two regions, basically, they happen to have the same value. So if we just care about in terms of value, I can always convert the one that I highlighted in yellow to become Pz greater equals to A for further calculation. Again, the region in yellow and also in blue, they happen to have the equivalent value in probabilities, or they have the equal value by the area. So therefore, I can convert Z less than equals to minus A, the probability to become Z greater equals to A. And from there, I notice that it will be 2 times of Z greater equals to A equal to 0.1528. And as a result, Pz greater equals to A equals to 0. So when the time we divide, we have it as 0.0764. And now, once again, we make use of statistical table to get the answer. By the way, how come I know that I can use statistical table at this moment here is that based on two criteria. First, the regions is happen to be this value here is happen to be less than 0.5, and at the same time I have the sign of greater or greater equal, either one will do. So as a result now, refer to table, and what we want to observe from table is that we want to find out Pz greater equals to what, which will give us 0.0764. And now let us refer to the statistical table for answer 0.0764. So let's see, 0.0764. So this is the part that I have the value 0.064, and is located 1.43. It is located at 1.43. And as a result now, I can state my answer 1.43, and then I compare these two parts I highlighted in yellow. I will have A equals to 1.43 as answer. Then we will go on with example number 3. So just have a quick calculations on the simple examples here to revise back how we happen to solve normal distribution where we need to involve of standardizations in our calculations. Okay, let's see. First of all, what I will do is that based on these questions here, you will know that X has a normal distributions with mean of 10 and also standard deviations of 2. First of all, we are going to need to state our X in the form of normal distributions. With mean of 10 and also standard deviations of 2. First of all, we are going to need to okay, go on. So X follow normal distribution is such that I have mean of 10, standard deviation of 2, and in here, when the time you write the distribution, we have mean and also variance, so should be 2 square here. Go on. Next, with this distribution now, we can solve for our part A, where we have X greater than 13. And how we get this answer here is that we will begin the calculation of standardization where I have my X minus mu divided by sigma. In this case here, your mu is 10, your sigma is 2. So therefore, the next line, you will see that I have Pz greater than 13 minus 10 divided by 2. And it gives me the result of Z greater than 1.5. Based on statistical table, I can just quickly get the answer equals to 0.0668. Go on with part B. I have P9 less than X less than 13. So go on. In order to get these probabilities here, again, I will begin the calculation with standardizations, where the standardization is just that the X I convert to become Z. The value 9 and 13, I just minus with the mean, divide by standard deviation. So I have 9 minus 10 divided by 2, and also 13 minus 10 divided by 2. As a result, I have P negative 0.5 less than Z less than 1.5. Once reached until here, after our standardization simplified, again, we try to observe from bell-shaped diagram and see the regions is referred to where. Middle is 0, negative 0.5 on the left, 1.5 on the right, and this is the regions that we're supposed to have. And in order to get this region shaded in red, what we can do is that we use 1 minus the regions I now highlighted in yellow and highlighted in blue, which is equivalent as 1 minus Pz less than equals to negative 0.5 minus Pz greater equals to 1.5. So this is the region in blue. This is the region in yellow. And if you notice the region in yellow, it actually have the same regions on the right hand side in such that I have Pz greater equals to 0.5. So let's have a quick look how this happens. Regions in yellow, this is the one that we have. If we have equivalent regions on the right hand side, such that the value here will have the same magnitude as negative 0.5, but opposite sign. So here negative, the other side will be positive. And the regions now will be z greater equals to 0.5. So we proceed our calculations by searching the answer for z greater equals to 0.5 and z greater equals to 1.5 from table. And you find out that you have 1 minus 0.3085 minus 0.0668, which gives me the result 0.6247. Lastly, example number 4. This question here is more real-life examples. Your exam question will be more like something like this, but I think will be tougher than this lah. This is just the standard easy questions. So let's see. When the time you have a real-life example like this, first of all, you need to identify what is the x that you want to discuss here. And the x happens to follow what type of distributions. So based on this statement here, from this first sentence, they say the height of the matriculation students in KMPP is normally distributed. So therefore, here we have the involvement of normal distribution with a mean of 170 centimeter and also standard deviation of 5 centimeter. And what is happened to be normally distributed, which is the height. And from there, the thing that happened to be normally distributed will happens to be referring to our x. Where in this case here, I will let my x to be the height of students. And to be specific, the height here, I mentioned it's centimeter, bracket in centimeter. And the height of student x is follow normal distribution according to this question here, with the mean of 170. The variance will be 5 squared. Again, I don't write 25 here is because later in my calculation, I need to use the 5 instead of 25. So I just put 5 squared so that easier for me to refer the sigma. Go on. After I'm clear about this thing here, now we go for part A. Find the probability a student selected at random have the height between 174 and 178. So in this case here, we are looking for probability for the height x between 174 and 178, which means that 174 less than x less than 178. No equal sign, because between doesn't involve of 174 and 178. Go on. Next thing what you do is that we go for standardizations. 174 minus the mean divided by sigma. X turn out become z. 178 minus the mean divided by standard deviations. As a result, what I have here is that I have P. So when the time I simplify, I have 0.8 less than z less than 1.6. Come up to here. Maybe we can have a quick look on diagram. How is the regions looks like? So here is 0, 0.8, 1.6. So this region shaded in red is the one that we want to look for. And from here, we notice that based on the regions, it can be interpreted as the probabilities of z greater equals to 0.8 minus pz greater equals to 1.6. Of course, again, ada equal sign ke tak ada equal sign sini tak penting, but let me explain to you how I get this idea here. So z greater equals to 0.8 is referred to the part that I highlighted in yellow now. Start from 0.8 until infinity. But you tak mau semua yang warna kuning ini. You nak sekadar yang shaded merah saja. So bahagian yang extra adalah bahagian yang sekarang saya highlight dengan purple. Jadi saya guna kuning tolak bahagian extra yang warna purple ini. That will be the regions in red that we want. Therefore now, as a result, what I have is that from statistical table, greater than 0.8, I get the answer as 0.2119. Greater equals to 1.6, I get 0.0548. And as a result, we minus 0.157 as the answer. So there goes the solution for part A. Then part B. Part B, please be aware these questions here. They say out of a group of 150 matriculation students, how many would be expected to have a height of less than 164 centimeter? So what we want in the final answer here is berapa students? Berapa students? Daripada 150. And apa kriteria kita nak? We want the height less than 164 centimeter. And in order to get these questions done, don't be panic. We always begin with the calculation of the probabilities of this event here, less than 164. So we start with probability X less than 164. To calculate the probabilities, standardize 164 minus 170 divided by 5. Simplify further. I have PZ less than. So when the time I simplify, I get the answer as negative 1.2. And once again, as a beginner, I will suggest that once you complete your standardization, you sudah simplify, cuba kita have a quick look mana kawasan dia. So tengah-tengah kosong, negative 1.2 on the left, and I want less than. This is the region. Then based on what we know about the properties of normal, I can have equivalent regions on the right, where the corresponding value here will be 1.2. Same magnitude but opposite sign. And this region in blue will be PZ greater equals to 1.2. And the region in the blue, we can get the answer from statistical table, and we find out that we have the answer as 0.1151. So this is the result of probability. We haven't answered the question yet because soalan tanya berapa orang ada. So this probability somehow to tell us that it's about 11.51% of the students happen to have the height less than 164 centimeter. So we make use of this percentage here and also the sample of student we have to estimate how many students is happen to have the height of less than 164 centimeter. And the calculations can be done as simple as follow, where we take the sample 150, multiply with the probabilities, and as a result, you find out your answer is 17.265. And if I convert into the nearest integers, it will be 17. So there is 17 students that happen to have the height less than 164 centimeter. And if I want to write in statement, so I can write something like this. I say about Sebab bukan exactly sama dengan 70, bukan exactly sama dengan 17. So I have about lebih kurang 17 students. Have the height less than 164 centimeter. And there goes the result lah for example number 4. Okay, so that's it lah for the normal distribution. Tomorrow we will continue with approximation. And once again, sorry for the disconnection just now. Bye bye.